Good day, class. Welcome to another edition of Class University Secondary School online chemistry class. I'm Solomon, your online chemistry teacher. In our last lecture, we were discussing chlorine, the remaining chemical properties of chlorine. And after that, we discussed some important uses of chlorine. And we also talked about how chlorine can be tested for in the laboratory. And here is the assignment of the last lecture. And here are the solutions to the assignment. Now, in our lecture today, we'll start discussing about an important derivative of chlorine, which is the hydrogen chloride. Now, under hydrogen chloride, we're going to discuss its occurrence in nature, its laboratory preparation and industrial preparation, its physical and chemical properties, and how hydrogen chloride can be tested for in the laboratory, and some important uses of hydrogen chloride. Now, hydrogen chloride gas was first prepared by Priestley in 1772, and he named the gas marine acid gas because he prepared it from sea salt. And we know that from our biology that sea salt or salty sea are also called marine water. Probably that's why Priestley named it marine acid gas. Now, under standard temperature and pressure, that means under standard condition or at standard condition, hydrogen chloride exists as a gas, but as hydrochloric acid when dissolved in water. Now, hydrogen chloride occurs in traces in air as an industrial byproduct. It is considered as a pollutant because it can be washed down readily by the rain because of its solubility in water. Now, the hydrogen chloride gas, after it has been washed down by rain, can cause harm to plant life and also can wash down paint from buildings or paint of buildings. Now to the laboratory preparation of hydrogen chloride gas. Now, hydrogen chloride gas is prepared by the action of hot concentrated tetrasulfate acid on any soluble chloride. Now we have different examples of soluble chloride. We have the sodium chloride, we have the potassium chloride, we have the magnesium chloride, we also have calcium chloride, and we also have other examples like that. Now, initially at low temperature, sodium hydrogen tetrasulfate 6 NaHSO4 is produced alongside some hydrogen chloride gas. Now this is the equation showing it. This is the sodium chloride reacting with the tetrasulfate 6 acid, the concentrated tetrasulfate 6 acid, forming the NaHSO4, which is sodium hydrogen tetrasulfate 6 and some hydrogen chloride gas, as you can see. Now at higher temperature, the reaction goes into combustion, forming sodium tetrasulfate 6 Na2SO4 and more hydrogen chloride. And this is the equation showing that. And here is the overall equation for both reaction. That means at low temperature and high temperature, here is the overall equation showing the two conditions. And here is the ionic equation for the reaction. Now to this diagram showing the laboratory preparation of hydrogen chloride gas. Now you can see that this is the sodium chloride as it is labeled here, and this is the sulfuric acid, which is also the same thing as the tetrasulfate 6 acid. The tetrasulfate 6 acid is added to the sodium chloride using this Tizzo funnel, as you can see here. Now you can see that it is applied, and the hydrogen chloride gas produced is directed into this conical flask containing the sulfuric acid. Now the reason for this is to remove any form of moisture accompanying the hydrogen chloride gas produced from this mixture or from this reaction here. Now after the moisture present have been removed, the hydrogen chloride gas collected dry is collected through the downward delivery method of gas collection, which is also the same thing as the upward displacement method of gas collection. And to the industrial preparation of hydrogen chloride gas. Now, hydrogen chloride gas is prepared industrially from the direct combination of hydrogen gas and chlorine gas produced during the electrolysis of brine. Now, please, I want you guys to take note that the electrolysis of brine here, which is used to produce the hydrogen chloride gas, is a little bit different from that of the electrolysis of brine we talked about in the industrial preparation of chlorine gas. Please let's take note of that. The hydrogen chloride gas produced can be dissolved in water to produce hydrochloric acid. And here is the equation. The hydrogen gas produced plus the chlorine gas produced are made to react to form the hydrogen chloride gas. And so the physical property of hydrogen chloride. Hydrogen chloride is a colorless gas with an irritating smell. It is 1.25 times heavier than air, and it turns damp blue litmus paper red, showing that it is acidic in aqueous solution. We all know that acid in their solution turns blue litmus paper red. Please take note, I said in their solution. It is very soluble in water, forming an aqueous solution of hydrochloric acid. Now, because of its solubility in water, hydrogen chloride gas is used to describe the Fontaine experiment. Now, we're going to discuss the Fontaine experiment in the next slide. Now, hydrogen chloride gas is also soluble in non-polar solvent like chloroform and toluene, but it will not conduct electricity when dissolved in this non-polar solvent, but it will conduct electricity when dissolved in polar solvent like water. Now, hydrogen chloride gas neither burn nor support combustion, hence it is used to extinguish a burning splinter. Let's take note of that also. Now to the Fontaine experiment. Now the Fontaine experiment is just used to describe the solubility of some gases, to describe how soluble the high solubility of gases. And the major gas we use are the hydrogen chloride gas, and we also use the ammonia gas. Now, but in our discussion today, we are talking about the hydrogen chloride gas. Now, you can see this is a gas jar which has a cork that has two openings, one for the jet tube, and the jet tube is directed into the blue litmus solution as you can see in the diagram. And we also have the other opening for the dropper. Now, this dropper is used to add water into this region containing the dry hydrogen chloride gas. Now, when the water is added to this dry hydrogen chloride gas and the blue litmus solution is forced through this jet tube. And now, as the blue litmus solution gets to this region, the hydrogen chloride gas reduces the atmospheric temperature and the atmospheric pressure of this solution, of this blue litmus solution as it is coming into this region, thereby forming a fountain-like structure, as you can see in the diagram. It is forming a fountain-like structure like this, you can see it. Now, the reason why the fountain water now turns red is because the hydrogen chloride gas, upon reacting with water molecule here, it turns the blue litmus solution red, which is the property of acid turning blue litmus solution red, as we said before in the properties of hydrogen chloride gas. So the chemical property of hydrogen chloride. Now, we're going to discuss the chemical property of hydrogen chloride as a gas and also as an acid. That means when hydrogen chloride is dissolved in water to form hydrochloric acid. Now, the chemical properties are not the same thing, but they show some similarities. That means hydrogen chloride as a gas, the chemical property of hydrogen chloride as a gas is actually not the same thing with that of hydrogen chloride when dissolved in water to form hydrochloric acid. But in our discussion today, in our lecture today, we are just going to be discussing the chemical property of hydrogen chloride as a gas. Now, in our first discussion, we are going to discuss the reaction of hydrogen chloride gas with ammonia. Now, when hydrogen chloride gas reacts with ammonia, it produces a dense white film of ammonium chloride. Now, this is the equation of the reaction. The hydrogen chloride gas reacting with ammonia to give you dense white film of ammonium chloride. Now, the second property of hydrogen chloride as a gas that we're going to be discussing is its reaction with metal. Now, hydrogen chloride gas reacts with many metals, especially when they are heated, to release hydrogen gas and form the chloride of the metal into process. Now, this zinc, for example, reacting with the hydrogen chloride gas, forming the zinc chloride plus the hydrogen gas. Now, please take note that only the metals that are more positive, that are more electropositive than hydrogen, would only react with hydrogen chloride gas to liberate hydrogen gas. Please let's take note of that. Now, if the metal can form two chlorides, for example, in the case of transition metals like iron, copper, nickel, and the other rest, the rest of the transition series, usually the lower chloride is formed. And you can see here the ion reacting with the hydrogen chloride gas, forming the ion 2 chloride FeCl2 and liberating hydrogen gas. Now we've come to the end of our discussion today, our first lecture under hydrogen chloride. Now here are some assignments from you guys, and I hope to see you again in our next discussion of hydrogen chloride. Thank you. Till we meet next time.